also has a hard stop to catch a plane at 4:30, so we are going to be done. No, we're going to be done at 4:30. Okay. So mostly we'd like to produce some interaction with the audience. So if anybody has a burning question, please step to the mic. Otherwise, I'll kind of start a little bit of the conversation. Let me start with a question to Stuart Russell, as it relates to your comments that ultimately computers will make better decisions than humans. And I wanted to ask you that question in the context of analysis. So the task of analysis is a hard one, and human analysts perform the task of analysis. So in terms of these better decisions, do you ultimately think machines will make better decisions than human analysts would be able to make? Can you sort of comment on that, expand on that?
So I have to, yeah, I think so. Partly because they don't suffer from either short-term or long-term memory limitations. So they literally can ingest everything the human race has ever written, and then synthesize, integrate that information, find connections. But doing that, one of the characteristics of analysis is that nothing is taken at face value, that you never assume that the identity of the speaker is known. There's always uncertainty about everything. And so this is one of the things that probabilistic programming languages actually handle very well. And that's one of the reasons it works so well for the seismic data interpretation, because precisely the identity, right? Is this blip, that's measured, on the Falkland Islands, is that coming from the same event as some other blip that's measured in Greenland? That's uncertain. And what it does is it sorts out all those possibilities across the entire planet by essentially looking for the combination of assumptions that is both self-consistent and highly supported by the data. So I think the big gap right now between what these systems can do and what a human analyst does is the background knowledge of human activities, of economic activities. And again, I just don't see how deep learning is going to do this. I work a little bit on financial data analysis and modeling the financial behavior of individuals. So if you take a model-based approach, you can build in the fact that there's such a thing as conservation of money. So if you spend $100, you have $100 less in your bank account. Deep learning systems don't know that, right? So that means they need, and for every one of those things they don't know about the world, that multiplies the amount of data they need by another factor of 100. And so the dream that goes back in AI to the early 80s and Doug Lennett's Psych project of developing that background knowledge, that common sense of how the world works, I think it's still unfulfilled, but it would have to be solved in order to build something that was a superhuman analyst. In the meantime, could you find ways of combining some of the capabilities of the machines, which are superior in sifting through hypotheses and finding ones that are consistent, detecting inconsistencies and so on, with human understanding of background knowledge? That's an interesting question.
So at some point, it's the case that humans would have sort of insight that machines wouldn't, but ultimately you see that crossing over. I think that's what you're saying.
Yeah.
Okay. Rao, did you want to weigh in?
Yeah. So I guess there are two issues. One is, at least in the beginning, sometimes somebody might actually do a better decision than the human analyst. The real question is, can they sort of convince the human analyst that they have actually made a better decision? And we can't, until we come to a point where there is like 100% certainty that the machines have all the knowledge and are actually coming to the right analysis conclusion, we will always need to be in the loop and we need to be convinced. And that's actually a technically challenging problem, as I was pointing out. Convincing a human in the loop is not a soliloquy. It's not machine talking to itself saying, yeah, it just makes sense because I did this, I did this, I did this, because humans hopefully have lives and they don't want to know what the actual step-by-step reasoning of the machine is, but getting a compelling explanation. That's one aspect. And the second is, while I completely agree that there are, we may not get 100% certainty, with the explicability, explanation sort of things, there may be a possibility of triaging the systems. I think I was talking to somebody earlier that you could actually use analysts even with lower level of experience to sort of see whether the machine is making completely stupid errors. And in fact, the interesting thing is, because of there is no shared background common sense knowledge that you have, these are all essentially narrow savants, and so they could make truly horrific errors which people can spot even without having humongous background in analysis of that area. So it might actually open a scenario where you'd have less experienced analysts working with these machines. But for that to happen, the machine should be able to kind of provide a proper interpretable reason as to why it came to its conclusion.
So, Rob, do you want to?
Well, I just wanted to...
Yeah, go ahead. Sorry.
Yeah, okay. So I just wanted to respond a little bit to what Stuart was saying there about the analyst, and particularly with saying that some of the capabilities would just be very difficult for deep learning to do. So I think, I certainly do agree with what some of the previous speakers were saying, that purely, if you have explicit knowledge, you should try and use that rather than trying to create a whole bunch of examples and then get the deep learning system to learn it. But the difficulty is in many situations, and I think the analyst example is a good one, the information is just not provided to you in sort of nice, explicit kind of, formal rules. For example, it's true that the machines have the potential to ingest information from all over the web and so on and so forth, but it's in an unstructured format, right? And so converting that to some sort of logical representation that you can then reason with, in and of itself, is just an enormous endeavor and completely impractical at sort of internet scale. And the Psych project, which Stuart referred to, I mean, that project actually, I think most people regard, perhaps I'm just biased because I'm in the deep learning part of the world community, but they regard that as a big failure. I mean, that was an attempt to sort of build this very structured knowledge representation, and hopefully there'll be some sort of emergent property from it. But it just never happened. And so I think, the sort of deep learning crowd are sort of betting on the fact that you can actually try and reason without, perhaps having huge amounts of structured knowledge available to you. Okay, so of course it means that there are attendant problems, of course, which means you now no longer have the ability to so clearly delineate the path by which you reach your conclusions and so on. But it does give you the ability to properly ingest. You can scalably ingest huge amounts of information with it, from real world sources, not from sort of idealized knowledge bases, which you would have to use if you didn't use the deep learning methods. So,
Manuel?
I just think that this concept of decision making is quite complex, because in some sense a data analyst, a human making decisions, is never a one-shot kind of decision. You kind of gain confidence that people make good decisions over time. So you make a decision today, then it proves to be right, you get some reward, you build trust in this decision making, and eventually people can explain why, and it's kind of a relationship that has a nature of temporal nature. I mean, it's not exactly something that immediately we are proven to have made the right decision or the wrong decision, except in maybe a few cases. And another thing that is actually fundamental for us to understand, and I can't wait that an AI system helps me helps me support or recommend decisions, is that if you think about the AlphaGo program, one of the things that it did remarkably was what we call, from a technical point of view, they explored the space of things that could be done beyond what was being taught as the ones that would make sense. So machines, AI systems, will have this amazing ability of following the data for sure, but eventually also trying, maybe in simulation, hopefully, things that are of great kind of like deviance from what has been done before. And that's how, in some sense, AlphaGo ended up like beating the humans, because it didn't play things that the humans were expected to play. I was talking with Demis Hassabis recently, and he was explaining how in some game, that the third game, the second game, this human who was playing with the machine, Lisa Doll, saw kind of a move of the machine, of AlphaGo, and was puzzled. How in the world did this machine played this? And it took off, went like for 15 minutes to think about how to respond to that, because it was so unusual, that type of like move. So I think that, which ended up winning the game. So maybe one day, if we think about these decisions, or trying to cure cancer or do something that is extremely hard for humans, maybe we have to let the machine try, in some sense, to explore this space of things that are not even conceivable by us, but eventually may lead into solutions that were not in the path of our reasoning, but end up achieving the objectives that we wanted. So I see a great potential for AI to enable us to explore a space that we kind of maybe don't have the ability to explore. And of course, it cannot be on the real world, and there are researchers, colleagues of mine, that work on this safe exploration problem. But it has a very beautiful concept from the point of view of decision-making, because maybe it will lead us to find completely new avenues of solutions to our problems.
So I'll pause to see if there are any follow-up questions. Yeah, go ahead.
So just to follow up to that one, as machines, explore state spaces where humans may never go and come up with solutions that humans may never discover, how do we as humans, particularly say in militaries, test and validate these systems to operate as we would in hopefully safe manners, or for humanity, so to speak?
Yeah, I think it's a challenge. It's a challenge, but on the other hand, one of the things that Demis was telling me also, Demis Hassabis, was that the moment AlphaGo won to Lisa Doll was fascinated by what he had missed. And he became like he became a learner now of how in the world did the machine come up with this, and open like all this mind of Lisa Doll. And Demis was telling me, AlphaGo was stopped, didn't care at all whether it won or it lost. And Lisa Doll was fascinated by even like rediscovering the game by seeing what this machine eventually showed. So I don't know exactly, to tell you frankly, from a risky point of view. This was a game. This is like things that people do. But on the other hand, it has an implication potentially in your kind of in worlds of great risk, that maybe we'll find methods to solve the problem without hurting so much somewhere else. Maybe there is this concept that, so just to wrap this up, there is this concept eventually that there is kind of like the perfect solution somewhere, and we are like applying gradients to our solutions and improve them slightly, where really the solution is miles away in another hill. And maybe if someone just jumps us there, then we can, as humans, do the gradient and polish. But in some sense, the machine may help us jump to the other place that we did conceive. And we could always not jump there. It's our choice. But I think that Demis made me understand that the great hero was Lisa Doll, who, after all, was now fascinated by learning more. And that's really how I see that humans and machines may interact. Humans may actually ask these questions to the machines may come up with this solution, something that fascinates us, that was outside of our scope of reasoning. And then magically we know more. And then we start working on that, and then we challenge the machine with more things, then magically the machine puts us somewhere else. And in some sense, we are in these kind of like using the computers for our benefit. And we drive these questions, and the machines end up like making us think about phenomenal things that maybe we didn't think about them before, and using different methods. But concretely, I don't know, but I just know that these machines will be able to do this type of interaction with humans.
So I think the point that you make is, how does the machine explain when, in fact, the human doesn't see that That's a very important point. In fact, oftentimes we are talking about explanations when the machines are making stupid errors and the humans have to catch them. But the real hope for AI technology is that they will find things that we actually didn't see. And there are two aspects to it. One is in computer science, we understand that generation is harder than verification. So things that we may not generate, if somebody else points out to us, oftentimes we might be able to see it. Sometimes. Okay, that's one aspect. The second is, of course, we are actually reasonable learners. So if it's, in the case of Liz et al., actually, I think in the entire Go community, as I understood, spent a bunch of time figuring out exactly why did this work, and then they have sort of newer technologies and that sort of thing that could happen. In the end, essentially, I kind of remember this Jack Nicholson character in, I guess, A Few Good Men, that sometimes you can have this, you can't handle the truth. You can't have the truth because you can't handle it. So I hope that won't come to that, in the sense when the machine does say something, rather than just assume, if that it's wrong, we may be able to actually either verify it or spend time offline. And once you sort of learn that it was right, it increases your trust. Next time around, you might require fewer explanations.
Yeah, I just briefly wanted to add, so AlphaGo knows the rules of Go, and they are wired in by the human. It doesn't learn them. And so it has a correct model of the domain. So if it says this move, moving on the fourth rank instead of the third rank is better, its explanation is, well, because I ran 700 billion simulated games and I win more often, right, which is not much help. So the human has to sort of pick apart the underlying reasons. But of course, if you don't have a model of the domain, there's no way it can invent a new plan for subverting the North Korean government, because it doesn't have a model of governments and humans and weapons and subversion, and it's completely meaningless. And so I do think that in some areas, for example, tax avoidance is an area where we can write out the rules. We can write out the rules of financial transfers and transactions and taxation, and we can actually invent new forms of tax avoidance. Right? We can say this set of laws has the following loopholes, right? And then we can fix the laws to prevent those loopholes. But that's a domain which is relatively precise and can be written down formally. I think in the areas that intelligence analysts deal with, it's much more difficult to write down the rules of the game and then find, without that, the process of finding unsuspected solutions to the rules can't even begin.
Okay, let me explore another topic a little bit. So Rao, towards maybe the back third of your presentation, you kind of skipped through a slide where I think you were going to talk about video spoofing, where I assume that basically these machines can study YouTube videos, and after doing so can produce a video that is essentially imperceptibly different from somebody speaking something that they didn't speak.
Yes,
can you expand on that?
So I guess the identity spoofing is something that is actually quite easy, at the possible level of technology right now. There are great examples, some of which I was just showing there. I think they had, for example, Obama say something that he didn't actually say in that particular speech, and you can't tell because the lip movements are exactly the right ones. And then they also had, in another example, they had actually, I think, an actor would be essentially making gestures, and Trump would actually be making those gestures in a recorded video. So this is kind of very interesting advent of our great strides in perceptual intelligence. There was this funny, we spent a bunch of time in that workshop that I mentioned in March at ASU on attack surfaces and AI. And one of the cute things that came up was, I don't know how many of you remember, but there was this story that Charlie Chaplin took part in a Charlie Chaplin lookalike contest and came in second. And there is this possibility that in future we'll all be Charlie Chaplins. We'll all be poor imitations of ourselves. Somebody else actually can spoof us. The real question is, you almost need like an anti-Turing test. You need to sort of figure out how to differentiate between the machines, the imagined reality versus real reality, and it can become quite hard. So these are attack surfaces that are actually becoming easy. So if you have I mean, somebody call you, with your mother's voice and say, knowing at least some background on your history and say, I need the following such and such help, it's going to be pretty hard for you not to actually, deal with that issue. And then that's sort of an additional angle on the cybercrime that's just being opened up because we can do voice spoofing and video spoofing.
I just want to add a small thing, and I really think that the amount of attacks and the what we can do with our technology seems to be unbounded. We really can do millions of things. And I believe that these examples that we know that even like, for example, in my cobot, who knows when they put the coffee on the basket, that's not the bomb that is going to be delivered to the lab. I mean, I don't have a bomb detector on the actual basket. So it's clear that, I mean, we are creating this AI technology extremely powerful. So I also think that it's clear that this technology did not come from the sky. It was invented by humans, human minds. It's in the clear path of computing when it started in the early 50s or maybe 40s. So this is not the path that suddenly they became, it's normal. What I believe it happens, I mean, when we talk about these things, that this is a kind of a call to humankind. It is a call to us. I mean, do we want to make good uses or bad uses? I mean, if someone invents a way that this video is saying something, and now what I say, Rao is going to say, the same words, and its identity, and all of these, well, then what? I mean, we can try to have mechanisms to try to filter these things and try to find them out, but, the human mind will be even better at whatever. So what I'm trying to say is that our only chance, and I mean, I keep saying these, maybe it's because I'm becoming older, I keep saying these, is that the only effort we should put on is, in fact, on educating people, nothing else. I mean, people are going to be the inventors of the use of the technology. Let the technology advance with its with what we need to still develop, combining the reasoning, the perception, the learning, to try to actually, manage these humongous amounts of data that we became now master producers of data, Fitbits and cell phones and Nests and Alexas. I mean, what in the world are we inventing? We are inventing millions of things that unless AI processes this data, who is going to look at all the videos that are taken in a city, if not an AI system? Who is going to process all the data we are collecting, our transactions and so forth? So it's kind of like we are on one side producing all this enormous amount of data. We are on the other side thinking, oh, no, AI can be that bad, but who is going to handle what we are producing? So the best way for us to think about, be it in the military, be it in government, be it in our homes, is to really have people invent good uses of this technology. It's not, we cannot do anything. The technology is extremely powerful. So it's investing on people, education, people, that's it. Investing on people.
I just want to add just one more thing. So I tend to be less sanguine about people's good intentions than my friend Manuela. I think we will find adversarial uses, but I think the big plus point is that AI can be part of the solution. When you open it, attack surfaces, it's not that only the bad guys have AI, the good guys have AI too. So in fact, if in fact your mother does call, at some point of time, we shouldn't be reading our emails. We shouldn't be taking our phone calls. There should be personal AI which screens. So your personal AI will call my personal AI and try to spoof it. And if I have the best version, then it will then let the call through. So my point is, I think we cannot assume that technologies won't be misused because, come on, that's exactly what we do. As a humankind. And I think humankind, not me. But I think we have to, but it is indeed possible that it opens up more interesting research problems, which is, how do you use AI as a solution to the adversarial things that were made possible by AI? That's very much, worth doing. So that's one of the things that I just want to mention.
I just want a very brief point. yes, there are people who do bad things, but there are many other spheres where people do bad things, and we have laws to make those things illegal. In these new areas, there are not laws, so it's completely legal to produce a voice synthesizer that appears to be your mother asking you to do something. It's completely legal to make a video of anyone doing anything, right? Now, just a simple rule saying, you know, even if you want to allow that, at least say, if this is synthesized and not real, it should say so, right? It should say, you know, just like for political ads, you have to say, you know, who paid for this ad, right? That's a rule, even though it's politics, which is very little regulated. Right, if you make a fake video of an actual person doing something that wasn't real, then it has to say so.
Yes.
Right? That seems like a bare minimum that we could do, but at the moment, nothing. Everything is, it's a free-for-all, it's a Wild West.
So just to say that making completely believable fake videos at the moment is probably, you know, it's automatically, without any, it's still a couple of years away, but it's certainly, you know, very much on the horizon. Yeah. And then, I mean, and then there'll be this, what we're talking about essentially is this arms race now. If you didn't have legislation between your AI, I mean, as soon as there's some AI technology for blocking, for detecting the fake video, then you could also then train the method that generated it to circumvent it as well. So.
Okay, that generated some questions. Right here, go ahead.
Sure. I guess one of the...
Pardon me. This is webcasted, so wait for a microphone.
Is there a portable mic? Yeah, there is. Thanks.
Several speakers have talked about you know, transparency and, you know, trying to get the AI to you know, basically do the right things, stuff like that. So as a kind of a expanded thought experiment, I just wanted to kind of talk about deception, because I kind of view, as a longtime AI guy, you know, deception is one of those human behaviors. And to me, actually, this was, what, 25 plus years ago, at Georgia Tech, they basically did the Squirrel Experiment. And I assume most of the people are familiar with that. But basically, for those who aren't, you know, squirrels hide nuts. So they have to make it through the winter, so they hide their little nuts at different places. So what they did was they modeled the behavior. So you have one AI who's the squirrel who's burying his nuts. The other AI is trying to find those nuts. And so the squirrel who's burying his nuts basically starts to deceive and goes to locations and things where he doesn't have nuts to basically fool the other squirrel where he may be hiding the nuts. And so what I thought was kind of interesting to take up to the next level is that really what you're starting to see here is that the AI is not only looking at the deception part, but also looking at how you would view that deception. So I want to talk about that.
Well, so we see this in poker, right? So, you know, how there's bluff and double bluff, and so the game theoretic solutions for games of partial information automatically produce that type of behavior. So they would do what the squirrels were doing. You know, but obviously if the squirrel spends all his time going to places where he doesn't have nuts, he's going to starve to death. So, you know, he's got to figure out what's the right... Right, what's the right balance? And you see the same thing. So I looked a little bit at this reputation falsification, for example, in eBay, where you create thousands of fake logins. It's called the Sybil attack. Mm. You create thousands of fake logins, and they do transactions with each other to raise their reputation as being honest, and then they'll start transacting with real people and rip them off until their reputation disappears, and then you make another 1,000 logins. And with the right detection capabilities, you can see these patterns of behavior and snuff them out. So then, you know, the solution ends up being that, yeah, they can still do it, but only at a very low level. If they try and do it too much, they're going to be detectable. So they can't look too different from an ordinary person, and an ordinary person is fine, right? So it's a very complicated game, but AI systems, I think, you know, have no problem creating 18 levels of deception. Right, so they could watch the Inception movie and they would understand what the hell was going on, right? You know, so I think you could get you could get AI systems to concoct schemes that could be extremely difficult for people to understand and detect.
Yeah, so I think, again, to me, deception is a higher level of intelligence, honestly. I mean, I think there are actual, studies showing that the kids only learn to lie after they figure out that their mental models are different from other people's mental models. So it actually cognitively higher up. And I think, so again, the ability to track what you are writing in the other person's mind and what their current status is extremely important. And that is, if I can cooperate with you, I can also deceive you. And the second thing is, in that workshop that I was talking about earlier, we talked about this fact that sometimes you might actually use sort of white lies to get people to do right things. For example, we all know what is healthy living, healthy eating, but we don't do it anyway. And so the question is, if there is a way in which people can essentially do some white lies and deceive you into doing the right thing. Now, of course, you could say, well, you're opening a huge Pandora's box, but the reality is we are being deceived anyway in other ways. So deception is not always just a bad thing, and it requires, it's a very interesting extra capability you get when you're able to handle the mental models of the others, which is an important thing. And I think, again, in fact, I mean, unlike what Stuart is saying, currently it's not very clear to me that AI systems that we currently have the ability to model other people's mental states. So when you get there, which I believe we will by doing research, then they will essentially do this deception. So when I go to these trust in autonomy workshops that military runs, so I'm actually sitting sometimes and thinking, do you guys realize that you are opening up yourself for a second order, end of the world, where essentially, I mean, the best Hollywood movies like Sting are, the entire movie is to kind of get you to get to a particular mental model and the last minute deceive you. And so you could have, machines which can do that too. They can essentially engender long-term trust in you only to change it. And of course, they don't have to be evil machines. They could be just controlled by somebody smart who is just, making this machine do that. So those are our issues.
I think the gentleman, did you have a question? Go ahead.
So you talked a little bit earlier about our inability to understand the failure mode of certain of these algorithms. And I want to take it up a level and think about the failure mode of the system of systems. We know that complex systems fail chaotically, high-frequency stock market trading, energy, electrical power grid, and so on. Is there research, or are you involved in any research looking at the failure mode of these systems of systems and our ability to detect and perhaps prevent or perhaps create chaotic failure in these systems?
So, I mean, I was only personally, in my own talk, I was just talking about the fact that perceptual systems have, individual systems have failure modes that we can't particularly analyze. The fact that general complex automation systems can have failures that will take a long time to analyze. I mean, so for example, the flash crash on the Wall Street, that's not, don't put it on AI, and at least as far as I can tell. And it still took a long, long time for people to understand exactly what crazy interaction between 18,000 pretty non-intelligent systems led to this particular flash crash. And so I think people may very well be working on these sorts of things, but I think within AI we are focusing, I mean, the specific part I was mentioning is, even for a single system, when it makes an error, you just can't see why it made an error. This is something different from what we are used to. Sometimes, as I said in that other, the Norwegian bus example, when I say I see burqa-clad women, you can almost see why I saw it. And that's a big issue because internal representations are not at all aligned, and that's going to be an interesting issue. So the great conference in deep learning is called International Conference on Learning Representations. If you had that name of that conference like even 7-8 years back, people would have thought that means representations that people might have something to do with, such as the logic and probabilistic logic and so on and so forth. Right now it is the machines learn their representations. You don't have to be part of it. And of course, you also don't get to be part of the dialogue with them. So that does open up interesting new challenges.
So one thing along these lines that we have been working on, if you ask about research and people have been working on, is this detection of anomalies. So basically people try to look at the way that the system is functioning and at least alert that the actual statistical performance of the system is diverging from the usual performance. And so that's why we detect anomalies actually in cobot or in the robots that were not predefined. For example, if a motor starts failing, we did not have a condition to detect that, but somehow the behavior of the system starts diverging from the residual behavior, and you can alert that something is not according to normal. So somehow we cannot explain why that divergence comes up, but again, the human plays that role of interpreting what is this failure all about, or the machine also can provide support, maybe like more cryptic about that anomaly, but that's how we interpret a lot of failure. So there are many of these kind of filters for failure detection on these robots. Of course, they are all kind of based on normal execution, and you assume that you have the concept of normal execution. But for example, if you unplug the camera, so the robot starts seeing many, in some sense, completely black images in its input to the reasoner, and that never happens. Sometimes so you have this detection that there is something anomalous, and of course, if it's really just a black building, which didn't happen to be part of the normal perception, it's going to detect an anomaly, and it was not. But so there is this concept of normal versus abnormal, and we can identify those as deviations from normal, and a lot of research is on that anomaly detection. And then, of course, the explanation part and why this is anomalous is all with respect to some normal behavior. And why, and so it's always about this differential, this deviation from normal. And that's the research we do in this type of like detection of failure.
It's a question for Stuart, following a very interesting comment that you made towards the very end, that there's way too, and I'm just paraphrasing here, there's way too much deep learning being done. Now, that's really, of course, credit to the University of Toronto and their spin-off. This is the old Marvin Minsky versus Toronto. And without knocking the University of Toronto system, they did a wonderful job, of course. But there's a lot more to artificial intelligence, as you pointed out, in machine learning than deep learning. So what is your assessment based on that, where, in other words, another way of asking is, how much attention should I pay to the non-deep learning part of AI? As you probably know, there is some commercial 90+% of the commercial startups are in deep learning. But there are a few, Gamelan, which is an MIT spin-off, that's looking at Bayesian approaches. So where's it, now I get a lot of information from my commercial folks, so they tell me one story, but from your perspective, where's that going, if anywhere?
Well, so I say this for a number of reasons. One, of course, is that I'm not a deep learning researcher, so it pisses me off. So you have to discount that part. But I run into a lot of CEOs of large corporations who have needs for AI that deep learning is not even in the business of being able to meet. And part of what happens is that if a problem is just completely not amenable to deep learning, for example, I have a factory and I want to schedule manufacturing for the next 6 months, which is 200 million operations and personnel assignments and movements. Deep learning is not even that business. So what tends to happen is that the problem is defined out of existence, right? It doesn't exist for the deep learning community because it's not something they can address. And that's really dangerous. Another symptom, for example, so Francois Chollet, who just wrote a pretty well-received deep learning textbook, he has a blog about the future of deep learning. So he talks about all the failure modes of deep learning and the walls that it's running up against. And then he talks about what might happen in the future to get around this. And it's distressing that he seems to be unaware that, so he talks about the need for, representation and reasoning about objects, but he seems to be unaware that anyone has ever thought those thoughts before, and that there's 2,500 years of literature on that on that problem. And he talks about the fact that we might have generative models with the expressive power of Turing machines. Well, that's exactly what probabilistic programming languages are, and that technology is 20 years old. And so he's talking about a distant future for deep learning where they've made it to 1997. And that's kind of worrying. I see this over and over again. The younger generation thinks that all there is to AI is chain rule, and that's it, right? There's nothing else, and then there's diddling around with layers, graduate student descent, and there's no way that approach by itself. I mean, it's an incredibly useful part of our toolkit, but by itself, it cannot get us anywhere close to human-level AI. You need the ability to have, knowledge is an important concept that's absent from the entire deep learning literature. We still need those capabilities, and I think the deep learning community can learn the hard way, or they could read something and learn the easy way.
I anticipate a couple of responses here. So, Rao, and then I'm guessing Rob. Yeah, go ahead, Rao.
So I think partly what we were trying to do, some of us in my talk too, is that it's an extremely useful tool, deep learning, and if you're talking to companies, asking them to work on technologies that might be useful potentially much later is not going to fly. But I think we are in a crowd here. We are also talking about longer term investments. It's important to remember that neural networks were given up for dead twice at least. Okay. It's also important to remember that essentially the people who supported neural network research were a Canadian CFAR organization. I mean, the US has large amounts of funding agencies, but there can be sometimes collective groupthink. And it's very important to sort of trade off exploration and exploitation. I think it's great to use the deep learning for what it's good for, but also to realize that there's a lot more to intelligent behavior than just being able to do immediate perception. So it's important to see what it can and cannot do. And that's what I was hoping, we will get across. So it's like, where is as Wayne Gretzky's famous quote of don't go where the puck is, but where the puck is going to be. And it's not clear to me that either Stuart or I or Manuel or Rob knows where the puck is going to be. But if we knew how to predict future well, then we would have been actually doing deep learning work long before. And it shouldn't have taken that long to come by false starts. So why do we think that we suddenly become smarter now and this is the only thing that will work? And so funding agencies in particular and policy agencies should be taking a longer view and then diversify their investments. And I think that's very important. And it's very important for AI researchers, of course, to be, not to reinvent wheel every evening. That just makes no sense.
Rob, Manuel.
Yeah.
Okay, so good way my thing. All right, so I guess just to discuss Russell, some of the points Russell made. So I think if you have problems where there is a formal definition of the task, then of course you should use all that formal definition. Okay, I don't think anybody in deep learning would ever say you shouldn't. Okay, now the catch is that there are so many problems out there in the world which just you can't easily sit down and write these things out. Now, so I gave some examples in my talk of like recognizing, objects and images, right? So it's just very hard to write down a formal definition of what a cat looks like. Okay, so people did try. I mean, they tried, okay, maybe we can fit a cylinder for its body and, a little sphere for its head and so on. This was a valid approach in the 1980s, and it just falls apart. These things are just too brittle. So this is why the deep learning thing has proven very successful when you don't have a precise definition. Okay, now the catch is, if you want to create a truly intelligent thing, do you think, for example, it's possible to write down a set of formal rules that govern human behavior? Okay, so I would argue actually it's going to be pretty difficult to do that. Okay, and so that leaves you with, two options. So one is you could try and do the whole thing end to end with deep learning, right? So you could try and there are some sort of deep learning, pure, true believers who believe that you'll be able to just hammer the whole thing with some giant neural net and you know, train on all the interactions and human observations on YouTube and Facebook and so on, and you'll be done. The sort of more compromised solution, which I think most people would come to, is that you know, you should try and learn, use the deep learning to sort of capture representations, which you then subsequently can you know, use in some sort of more structured reasoning system. Okay, so that's a sort of hybrid between the two schools. So I think, you know, it depends exactly who you very much talk to as to where you'll be between the sort of end-to-end. The deep learning community, you know, people will be somewhere between those two things I described, and some people will be pure on the deep learning end of things. But
just I completely agree with Rob in the sense, and I agree with Stuart and Rawat. I've been doing symbolic reasoning and planning forever, but I have to tell one thing that I find fascinating: the difference between the past and these days is the data thing. In the old days, we used to think that AI would rely on knowledge that we would acquire from people or from models. We would write by hand. We would ask, how did you make the diagnosis that this person has some disease? And the doctors would provide that knowledge, and the architects would provide the knowledge how they designed these. And everything was about extracting from the human minds this knowledge that then became our logic. And yes, I pick up the block if the block is clear, and all sorts of like knowledge that came from a lot of like people spelling out what they knew. I think that currently we are leaving a signature, a footprint of everything we do through these data. So somehow it's a very interesting concept that we are revealing everything, the pictures we take, in the GPS we go, routes are revealed, everything. So it's a big difference for AI to really ignore. We cannot just ignore these data. And deep learning, in some sense, is extremely appealing and powerful, like Rob is saying, to really look at data. Maybe we know models, maybe we can use them, but magically now we have how we use, and when we do laundry at home, our meters capture. The whole thing is data that now becomes available when we can magically learn and predict at what time is she going to do her laundry tomorrow. So what I'm trying to say is like this. We cannot avoid thinking that the challenge and the opportunity and somehow the excitement involves data. It probably also will have to be merged with models and other knowledge of people. Even AlphaGo used some research algorithm. It was not just data. But the fact is that we are in the infancy also of knowing how to process data effectively. We are, because we have all this data, and we have to actually look at cameras in the city of New York or in the city of Pittsburgh or in the city of whatever and figure out what's happening from those images. And we don't really can sit down and write the logic for, yes, the car is going to 10% of the cars turn left, 90% turn right. No, the data tells it a lot. So I actually believe that a lot of what we do now has to do with data. Even like it has to do with data and the ability to process data, may be driven by, I mean, we may put knowledge on top of it, but it's fascinating to think that data will reveal so many things that we may not have known before. And yes, the models will come, and yes, eventually everything will be about, but what these startup companies, these new companies need to know is that we actually have to become extremely proficient at processing data with biases, with underlying models or not, I don't know, but what matters is that this data is available, and we cannot afford to disregard the data, and deep learning is giving great tools for processing this data. We are there, but don't forget that every single thing we buy new, be it our cell phone, be it our thing, be it anything, is producing more data. It's everything that we have is about data. And I think that we have to embrace that as the AI challenge now also, which is process that data. So, yep, I like models, I like logic, I like probabilistic programming languages, everything. But yes, there is data. And we do need to be very, very smart about developing techniques that process that data. Whether that solves the whole problem, I don't know, but we can just not ignore that. We cannot ignore that the data is there, which has embedded a lot of knowledge, because as opposed to data in the past that could be capturing what are the images on satellites, this data is capturing how humans function. It's my GPS that's there. It's the pictures I take. It's at what time I take breakfast. It's the things I buy in the supermarket. It's revealing humans, how humans function, not just how the satellites or the planets move in space. It's not. It's our life, the doctors, the health, the tests I have, my Fitbits. It's our life that is being digitalized. It's the human life. It's the human processes, not just something else. So that's what I think it's exciting, and we cannot deny it, and I think that's very exciting.
Say something?
I'm
Yeah, so I think it's not, it wouldn't be accurate to say that the model-based AI community denies the existence of data. Of course, right, you know, machine learning predates deep learning by many decades, and lots of work has gone into learning model-based representations. You know, that goes without saying. But learning into what, right? This is the fundamental scientific question, right? Sure, there's data, but what is it that you extract from data? And one of the clear things about the world we live in is that there are things in it. Things, chairs, people, right? And relationships and events. Unfortunately, deep learning is just circuits. So in circuits, there is no representation of things and relations. It has to be supervened on top of that. To me, it doesn't make sense to expect the deep learning system to discover that the world has things in it, to invent the notion of relational representations and then logical or probabilistic inference on top of that. We know these things. We know the world has things in it. Why don't we take advantage of that in our formal representations and our learning algorithms?
Do you want the last word?
So, there are systems that run, you know, in real practical problems which do model using deep learning methods relationships between objects. You know, they have quite heterogeneous collections of things and so on and so forth. So, for example, this is a project at Facebook, which, you know, Jan's talked about, which is where, you know, every single different object in Facebook, image, post, you know, people, everything are just represented as a high-dimensional vector in some space. So, in other words, the deep learning part is taking that thing in the real world, turning it into just a high-dimensional vector. Okay, and then in that space, you can do all kinds of reasoning tasks you want to do about, you know, who's friends with somebody, who might like something, and things like that. And so, you know, it's somewhere between a completely abstract, you know, uninterpreted representation and a sort of purely formal, you know, logical representation of that individual or that entity. Okay, so it's soft, it's continuous, it's just a bunch of numbers. But if you take, you know, nearby vectors in that space, that means they're probably the same thing. Or if you have, relational operators that apply to the, you know, pairs of objects, they can tell you whether, you know, some relationship between them is, you know, is this, you know, it's not a physical scenario, but you can imagine other versions of this would be like these two objects, you know, related to one another, or they somehow physically connected, or, you know, to one another, and things like that. So it is possible to do kind of reasoning tasks, I think, and to sort of instantiate real things in the world using deep learning in a way that you can actually achieve, you know, do real things with them. And so these things are actually used the whole time for, like, you know, finding fraudulent activity, you know, making all kinds of predictions and stuff like that. So these are real systems.
Rao, did you want the final 30 seconds?
Okay, I guess I can say something non-controversial. I think we are not actually arguing against any subjects here. I think it's this. There are two different things we talked about. One is data versus knowledge. Whatever is available, you want to use it. Okay, it's silly to say, give me data when I want to give you knowledge. It's also silly to say, convert your data into knowledge and give it to me. AI technology should be able to use both of them, and that's the point that I was trying to make. The other question, of course, is which technologies are likely to be able to be better at using data versus knowledge? That's a research problem that we have not completely solved. I think, I find both the arguments, reasonably compelling, that there may well be other interesting ways where continuous representations might have modularity properties. But we do want to get there. I don't want to be forced to give my knowledge as bazillion examples just because that's all the machine knows how to use. So we need to be able to use both of them, data and doctrine, and that's what I would like to say.
Okay, almost to the second. So we promised a 4:30 adjourn time. Thank you for being here. I hope this whetted your appetite on this important topic. Please join me in thanking our panelists.